we look after the high performance computing facility. I'm going to tell you about that. So I'll give you a bit of background, try and explain what high performance computing is and why you might be interested in SHA. I'll tell you what we do for central HPC at Sheffield. And then I'm going to finish up with how we're going ahead in the future. So just to feed into what Andy said, you're interested in hearing what the future developments are. High performance computing, it's used across the campus, across all faculties, science, medicine, social science, arts and humanities. Quickly moving on from the spelling mistake. Many projects. I can't do justice to it. So I think this backs up the previous slide. We've got all the faculties covered, with the exception of arts and humanities. Okay. So computational modelling. So modelling of fluids, modelling of solid structures. Psychology and robotics, looking at interacting neural networks. So trying to study the dynamics of the brain. So we have projects that are building models of the ant brains. Building a model of the fly brain. And they're connecting the work that they're doing in that area with robotics. A lot of the work is cross-faculty as well. So what actually is high performance computing? Right. So I can define two kinds of approaches. It's the idea of aggregating compute resource. So you have a large computational problem, a challenging problem. You find that your laptop or your iPad isn't good enough. You need more power. You need more computational power. So what do? You take the computing power of many cores, many processing cores, and you join them together, and you get them to work on a problem in that way. So one of the easiest ways is to look at what we call a task array. So we can take a problem, we can split that problem up into many tasks, and we take each of those tasks and we get each task to run on an individual processing core. These tasks, they don't have to run at the same time, so that's quite important. Typical examples of that might be running many different kinds of models with different parameter sets, pattern searches in data. So the next kind of computing we call capability computing, or what we call parallel computing. So in this case, we still split the problem up. We distribute the problem somehow across many processors, but this time these tasks are dependent on one another. And at each iteration or each cycle, you need to communicate data between the different processors. And that's typical of, say, modelling a fluid, modelling the flow of air around a football that you might have seen in the previous slide. You need to communicate information about what the air is doing on one side of the ball and the other. Okay. So in that case, each of your processors needs to send information from one processor to another to allow the computation to continue. So you can see that the earlier case we normally find is easier to implement. Okay. So how do you get something like this to work? Well, what you do is you take many processing cores, and that could actually be a laptop. So modern laptop might have 8 cores. So it might just be a simple method of getting all of the cores on a laptop to work together. But in the case of a HPC cluster, we have many workers, we have lots of users who all want access to each of those workers. Each worker is an individual processor, is an individual computer. It has the same operating system in our case, and it can see the same software stack. You have a gateway onto that system as well, so you have what we call login nodes. You also have head nodes which manage the whole lot. And the other bit in here, this spot in the middle, is the file store. So the key thing is that they can see they have the same operating system, they have access to the same file store. So in that way, it makes it easier for us to manage the system, and it also makes it easier for the user to request the resources that they need to run. So we've been doing high performance computing for quite a long time. We started off with the White Rose grid. At that point, it was mainly capacity computing. We did lots of task arrays. And as time moved on, we started building in different technologies. So we introduced an interconnect. So we had more and more users doing parallel computing, lots of that fluid dynamics. And we had partnerships with departments as well. The next generation, probably the main sort of feature of the next generation, 2011-13. So Iceberg started off in 2005, okay? And we grew Iceberg. We had research groups joining with us. They wanted us to expand the cluster. We had a framework, a procurement framework, which allowed us to buy infrastructure for researchers on campus. Features of this generation was a new data storage system. One of the challenging things is to so you've got 1,000 users on this system. You've got lots of processors. They're all trying to access data storage, and you need to do that very efficiently. So we have a fast data system. We're also introducing new technology for doing the communication as well. Last year, we continued. We had the end of the HPC framework agreement. We had to go to another tender. We grew the fast data system. It's well used. And we then developed a new research file store. Okay. The feature of the file store is that it's accessible from, the new feature of the file store is that it's accessible from not just the cluster, but from users' desktops as well. So what do we do as a service? Well, essentially we provide this central HPC service for the University of Sheffield. And all users have access to a free level of service. But we can also provide dedicated hardware for research groups. You can use the procurement framework that we have to procure hardware if you need to do that. And we can host that hardware within the central HPC facility. Now, we have an oversight group as well. So this facility is sort of managed with the help of a research computing advisory group, academic representatives. We have representatives from SHA. They advise on usage policies. We run a HPC at Sheffield event, so the ARCAG help organise that event as well. So this HPC system provides free resource to all users, but sometimes you don't want to join the queue. You need dedicated access to that resource. So we're able to provide dedicated access for research groups to that hardware. So there's a number of options. Now, as part of this service, we need to tell you how to use it. So we do a lot of training and outreach as well. We've got training which is delivered as part of the doctoral development programme. We do an annual HPC Sheffield event to publicise what we're doing. And we also have networking events with the N8 HPC consortium. Access, to get access to this, you can just email us, researchit@sheffield.ac.uk, and we'll give access to researchers to any of the HPC services. So, what happens if you want to go beyond Iceberg? I mean, we're not providing enough compute resource. You're having to wait for stuff to become available. Well, as I said, you can purchase a slice of Iceberg. You can get access to the Tier 2 facility. So we have a partnership with the N8 institutions. We have a facility which is based in Leeds. Now the University of Sheffield owns 1/8 of that, and we manage that facility for the University of Sheffield. Also, as part of that facility, they have the Herc 1 machine, which is part of the FAR Institute. And if you're still having trouble, you might want to use one of the UK national facilities, like Hector or Archer. Hector's the old machine. So we've got a lot of things that are happening. So I mentioned the end of the HPC procurement. We went ahead with another procurement.
Sorry to disturb you. You've got tea and coffee at 3 o'clock.
Yeah, I believe we have, yeah. We're doing things with remote visualization, and we have sort of virtual machines for research as well. So we're not doing just high performance computing. One of the things about the HPC cluster is that there's the challenge of making the cluster more accessible, making it easy for researchers to use. So as I mentioned, we've gone ahead with another HPC procurement framework. It's been extended for 2 years with Dell. We've purchased a new facility in partnership with another project, the Polaris project, a lung imaging project in Hampshire. So the new cluster, it's 1,000 cores. It's got a 600 terabyte fast data store. It's the same as the old cluster. Boring, but reliable, right? It's not boring, believe me. But boring is good when you know that it works, because we're trying to provide a reliable service. Okay. The big challenge for us, the excitement, is the Omnipath network. So that's going to be the big change for us with this new cluster. Accessing it will be just the same as Iceberg. We expect it to be available early in next academic year, 2016-2017. Accessed in the same way as Iceberg. If you know how to use Iceberg, you'll know how to use Shark. Okay. And the file store is accessible from Shark and Iceberg, but not the fast data. Other things that we can do, you might not want to use. I mentioned that the cluster has the same operating system across that system. You might not want to use our operating system, or the software that you have might not be compatible with that. You might want to use a machine in our virtual machine pool. So in CiCS, we can provide Linux and Windows virtual servers, in that case, where you need to host your own applications. We've been doing that for a while, but the applications that the machines that we've been supported are not really suitable for computation. So our next development is research virtual machine pool. So you can now use our virtual machines for computation and for larger sort of memory tasks as well. The other technology that we're doing, so the other feature of HPC is when you have this concept of submitting jobs. So you have a job, a large compute problem, which you set up and you submit it to a queue, and then you come back and you wait for it. So a lot of researchers want to work interactively with the data sets, with the applications that you're using. You might want to visualize data sets. So the nodes on Iceberg, on the cluster, they're just nodes for doing computing. So one of the innovations that we've been looking at is allowing researchers to access machines that have graphics cards attached to them. So you do all your graphical rendering and your visualization actually on the Iceberg cluster, but we're using nice sort of graphics, high quality graphics cards to do that rendering. The difference is that those rendered images are then transported to your desktop using something called virtual video. And that gives you a high degree of interactivity. So there are lots of different ways that we're trying to investigate for making applications more usable for users. So finally, research computing across the campus. I started out giving a great long list of research projects, and you can go on. So you can see that there's a need for a lot of support for research IT across campus. And part of this, we had a set of recommendations that came out of a project a couple of years ago. There was a recognition that there's a greater need for support. So who's going to support all this infrastructure and all the applications that go onto this infrastructure? Okay. We have three areas in this new group. We've got an infrastructure area, a software area, and a storage area. So you'll hear more about software from Mike. You'll hear more about storage from Jez. This new group will also be headed up by a new researcher of IT. So these are developments that are taking place. We will have, over the next couple of years, research support staff recruited into these three areas. Getting help, our main website, www.chef.ac.uk/kicks/research. So we've got links for help and support on using the cluster. I mentioned the researchit@sheffield.ac.uk address as a point of contact for help as well. I think you're going to make the slides available. So, yeah. And yeah, thank you.